Hello and welcome to Thought-Provoking Tech. I'm Zach and this is Trial and Error. In Trial and Error, it's a new show that I'm introducing in this episode. And the idea behind Trial and Error is following a project from the very beginnings all the way to the finishing results. Whether those finishing results are achieving the goals that I set out or the project ending in a flaming pile of components. I hope that doesn't happen very often, but that's kind of the nature of these videos. Kind of showing the entire process of a project, cutting some parts out, of course, multiple iterations of programming, that doesn't get too interesting, but I'm trying to get some cuts and show projects through the different phases and kind of give you an idea of and a viewpoint into the work that goes into different projects. So in the very first series, I'm going to be making a drone from scratch. I could just go out and buy a cheap drone off the shelf, or even buy a pre-made kit that had like a flight controller. But I kind of wanted to take a little bit different look at it and kind of start from the very beginnings. I do have some pre-made components. For example, a hobby mate set of two clockwise and two counterclockwise motors and 4 ESCs that came with them. But some of the components will be completely scratched. For example, this Arduino Mega. I will probably downsize to a smaller Arduino, but they have tons of ports with the Mega, and beyond that, it has tons of storage space and a ton of memory. So that means I don't really have to be conservative right off the bat, which isn't necessarily the greatest process, but as I'm kind of working through the process, sometimes it's just nice to get some code out there and get stuff functioning and then kind of trim it back in the future. So once we're actually ready for takeoff, we'll downsize and that and stuff. But that's kind of just the nature of how I actually do my projects. I kind of start with some set hardware and just kind of evolve it from there. So I hope this video series is going to be exciting and kind of show you kind of the different aspects of a different project. So this will involve everything from 3D printing. I am going to be making a different channel focusing on 3D printing, but this will have 3D printing, electronics, programming, pretty much everything as these projects kind of start from the very beginnings and evolve into the future. With the drone project, if it gets off the ground, I have other iterations that build upon this kind of framework that I'll be building in this series, such as making it autonomous, making them work in packs so they can function together, communicate, and kind of go to a set target or achieve a goal kind of together. So some very cool stuff in the future, assuming that I can get this project off the ground. So without further delay, let's go ahead and get started on the very first episode of Trial and Error. Alright, so the first thing on this project is I'm going to do a quick solder and get the motor connected to the ESC before I connect anything to power. These are just to be very temporary, just get me through the process of kind of learning how to control the motor, and once I have that done, I plan on the next stage of this project being designing the framework. A lot of these are like made out of carbon fiber, which is a little bit stronger, of course, than your standard plastics. But I'm going to try printing a frame out of 3D plastic, primarily PLA. Might go to ABS. It is a little bit more impact resistant from my research. But I'm going to try with PLA and just kind of see if it can sustain that, if that's going to be something that's going to be possible or not, and then go from there. I hope that something with 3D printing works fine. I kind of have the suspicion that it will be fine. It might not be super sturdy, and I don't think these motors are going to have enough torque to really be able to lay something out. If not, my next kind of avenue is designing something out of metal. The metal I have access to the easiest, I guess, is stainless steel. I'm not too keen to design something out of stainless steel, primarily due to the weight of the metal. But I might be able to get some aluminum sheet metal, and that's a little bit lighter weight and might allow a better heavy-duty drone. And once again, carbon fiber would be the ideal solution. I just really don't have an avenue of access to any carbon fiber. Alright, so the ESC has now been soldered to the motor, and now I'm just going to go ahead and plug the drone into the board. You want to use one of the PWM circuits when doing anything with the Arduino, and you'll plug your black, of course, into ground, one of the numerous grounds that you have, and then your other port into one of the PWMs. So the Arduino Uno and the Arduino Mega both have numerous PWMs, so what you're looking for there should be fairly easy to access. I'm going to go ahead and hopefully hold on to this whole assembly with the claw without putting too much pressure on that. And crib anything, I think it should be fine. I need to get some teeth or something, or some like teeth, like little rubber pieces put on the teeth or something, just so they don't cut into stuff as bad. But I think I am now ready to go ahead and start testing stuff. So I don't really have a LiPo battery like you'd really want with a drone. So I'm just going to test with a lead acid battery. This is a 12 volt battery. So what you want, oh my gosh, it beeped. I don't know what that means, but so lead acid batteries don't have the current capabilities that a lot of your LiPo batteries have. Just want to see if there's any LEDs or anything like that. Doesn't look like it, but for quick testing, it's not really going to hurt anything. This is a 2S to 4S motor, so that it will be the 12 volts is right in the middle. 2S is like roughly 7 volts, and 4S is roughly 14 volts. A little bit of there's a decimal place in that. I think it's, don't quote me on this, but I think it's 7.4 and 14.8. I'm not 100% sure on that though, but 12 volts is on the higher end of that. I do plan on using a 3 or 4S battery with these motors. Alright, so I now have a little bit of code written up to control the ESC. It should start at roughly 25%, or well, at 0%, ramp up to 25%, and do little bit pauses with ramp ups between each quarter all the way to 100%, and then it will ramp down from 100% slowly down to nothing at all. So this is just going to test different stages and just test the overall code and just see if I can actually control the ESC successfully. And if that's done, pretty much ready to get these mounted onto a real surface. So I kind of have it just held on with this little the clip with my extra hand station. So it's not held super tight, so I'm gonna have to disconnect it pretty much surely if it goes flying. But I do plan on getting the actual frame built at the very next stage. I just wanted to go ahead and get the ESCs and kind of learn how those work before I go any further. So without further delay, let's go ahead and try and see if this code works. So started the upload process to the Arduino Mega. You can see the little lights went off. Alright, so it's doing the slow ramp up, and I'm going to get out the way. So should be getting close to 100%. I should have put some serial printouts to give me the current state, but there just hit the command to ramp down, and now it's going down to 0%, and it should kick off and stay off for about 10 seconds and actually repeat the process here in a little bit. So we'll see if that happens, and then I gave it about 10-second pause, so I plenty of time to disconnect everything after the test. But it held pretty tight, so happy with that. So yeah, it looks like it's working pretty good actually. So I'm ready now, I think, to do the frame. I'm just going to let this run one last time and just going to disconnect it and go to kill the power when it shuts off. But the next stage now is to design a frame, 3D print it, and see how the 3D printed frame holds up to the forces that these motors put out. Other than kind of where they at the initial stage, they kind of look like a little bouncy. Once it gets ramped up, it actually seems to be pretty stable, even with this clip doing fine holding it up. So they just kicked off. I'm going to go ahead and plug the main power line to it and go ahead and disconnect the Arduino Mega from it. So even with the lead acid battery, which doesn't do a lot of, you can't get a lot of amperages generally out of those compared to what you can get with the LiPo batteries. For one motor, it's plenty to test it, and we have a successful test. Let me know that I can go ahead with this project going to phase 2. So I'm going to go ahead and jump to the computer real quick and just kind of walk through the code on how to get the Arduino to control the ESC, which will then control the motor. It's pretty straightforward. And then after get that completed, we'll be ready for phase 2, which will be designing the body with the 3D printed and getting that assembled with all 4 motors and getting the Arduino Mega to control that. Alright, so I'm ready to go over the code that allows the ESC to ramp up from 0 to 100% and then back from 100% back down to 0 and stay off for about 10 seconds. So the first thing you're going to do is include your servo library. Your ESCs will be controlled through the servo library, and essentially ESCs take input from 0 to 180. So when I'm going in 25% chunks that it ramped up in between, that's essentially 45 chunks of 45 inputs from 0 to 45, 46 to 90, and so on and so forth. So just for reference, that's kind of how you control your servo. So 100% is actually using an input of 180. Little bit confusing if you're not used to controlling them at first, but something that's fairly easy to wrap your head around once you've done it for a little bit. So the first thing I'm doing is making an instance of a servo and calling it motor 1. To make a quadcopter, you need 4 of those. So essentially, once I'll do when I have a frame designed and 3D printed, is make motor 2, 3, and 4. Int motor 1 pin is essentially setting that servo to that pin. You want to use a PWM pin, which there's quite a few of them on the Mega. I think there's like 10 or 12. So depending on how many motors you're going to have attached, you kind of have to keep that in mind, and how big of a drone you're making. And then the min and max are optional inputs into your attach. So jumping to the Arduino.cc reference, which is great, especially if you're starting out, very good. They have some good examples. But the servo library is very straightforward, very basic. There's not a lot to them. So the first thing you're going to want to do is attach your servo to that pin. So you can supply just the pin, but you can also supply a minimum and a maximum. And that's what I'm doing here, because in my little bit of research that I've done, to have the greatest compatibility with all ESCs, I saw that by default your minimum is 544 and your maximum is 2400. And I saw that to have the greatest compatibility, you wanted a minimum of 1000 and a maximum of 2000. So I went ahead and did that and sent those to the attach. So essentially, motor 1 is being attached to motor 1 pin. So from now on forward, whenever I call motor 1, it's going to send that signal out through that 8 pin that I have set up. There's a couple of delays here. There's one at the bottom too. Percentage delays. Essentially, I have it going from in chunks of 25%. And in those 25%, after each it makes each mini go, which is a 25% chunk, it'll just pause for a second. I could have paused for longer just to kind of give it more clear that you knew that it was at that point and then ramping up more. But it wasn't too imperative for me to have that big delay there. I just wanted to do it just to do a little bit of testing. And then the ramp delay in each segment, each 25 segment, since those are between 0 and 180, you have to take your 180 divided by 25%, which is segments of 45. So each quarter or 25% of your ramping up of your throttle is actually a range of 45 integers. So it's a little bit confusing at first when you're just starting out. Once you get a hold of it, it's pretty quick to and easy to understand. So I'm delaying a little bit between in those ramp ups, and then I'm doing a little bit longer delay once it reaches that goal before it starts the next ramp up. And then the motor throttle and the throttle are both being initialized at 0. We'll set those later. And then the end delay is once it gets all the way up to 100%, it'll ramp down to 0%, and then it'll do a big long pause of 10,000 milliseconds. And anytime you see a delay, it's most likely in milliseconds by default. 1,000 milliseconds is equal to 1 second. So you can see that percent delay is actually a 1 second delay. The ramp delay is a tenth of a second. And your end delay is going to be a 10-second delay. So the first thing, once you have all that initialized and set up, your setup is going to call motor 1 attach. And like I just said and previously, that it's attaching motor 1 to that pin. And now we're going to write motor 1.write and throttle. Throttle is initialized at 0. So it's essentially saying that we're going to start the throttle at 0. So the throttle is going to start off. Now we're going to do our loop. If you've never done an Arduino before, a loop is going to, your setup is going to be ran once. Once it gets power, every time it gets power, the Arduino will run the setup, unless something happens that the memory on there gets corrupted somehow, which I've never had happen. But every time you give power to the board, it'll run setup, and then it'll run loop over and over and over again, unless you actually kill the loop. And there are ways to do that, but most of the time people don't do that. So in our loop, essentially, if my throttle is not 180, so if I'm not at 100%, if I'm less than 100%, I'm going to run this check of code. Otherwise, if I'm at 100% or 180 on the servo or greater than that, which I have set up so you really couldn't get it greater than that, for instance, if it was greater than 180, equal to or greater than 180, it would run this check of code. So the first several times it's going to run this chunk of code. Throttle is going to be equal to a throttle plus 45. So it is initialized at 0 at the very beginning. So the first time it's going to be set to 45, and then it'll be set to 90, and then 135, and then 180. So 45, like I was saying, is 25% of your 0 to 180 range. So I'm essentially throttling up to a maximum of 25%, which is 45. Motor throttle is going to be equal to motor 1.read. That's essentially getting the current value of motor 1.read. Now we know that the first time it's going to run this loop, motor 1.read is going to be equal to 0 because we've set our motor 1.write equal to throttle, which is 0. So it should have set that to be off. But it just reads it just to double check. You always want to double check. You never want to assume anything with electronics. It could be a short out or something. And if you have a short, you're probably not going to get a good value back. But, you know, just for always verify yours, what you think should be happening. And so this chunk of code is going to run a loop. Anytime you see while, it'll run everything inside these brackets until this statement is verified. So your motor throttle, which you see here, which I accidentally introduced a typo in there when I was formatting it better to show it off. The motor throttle, twice. Let me fix that real quick. The motor throttle is, while that is not equal to the throttle, so at first it's going to be 0, and it's going to slowly increment that from 0 to 1, 1 to 2, 2 to 3, and so on and so forth. You get the idea through this function. So while that is not equal to the throttle, so while motor throttle has not equaled to 45 in the first instance, because 0 plus 45 is equal to 45, it's going to keep on running this loop. So then it'll do motor 1.write your motor throttle plus 1. That's the tongue twister. So many throttles. Should we thought how I was naming all these variables. So essentially what that's saying is it's going to increment your motor throttle, the current red value, by 1 each and every time in this loop. And then you're going to set your motor throttle. Did I typo that up here wrong too? Okay, no, I did not. All right. Jeez. That's what I get for copy and pasting. I tried to format this a little better to make it easier to understand for beginners. And I introduced typos, so sorry about that, guys. Anyways, back to the code. Motor throttle is gonna be red because we just told it to increased by 1, so we want to reread that to verify that it actually did increase by 1 and never assume anything, like I said. And now we're going to do that short delay that we talked about. And then, since we're in the while loop, it's going to initially, we're going to read that once again, and we went from 0 to 1, so 1 is not equal to 45, so it's going to run the loop again, and again, and again, and again, until that plus 1 is finally equal to 45. And then it'll run it when it is equal to 45. It'll run it one last time. You'll see 45 is equal to 45. It'll kill that loop and will exit that while loop. Then you'll do a delay, percent delay. That's when that big long 1% delay is introduced. And then it'll loop back around through the whole loop again. And it'll go back to loop. And our throttle is now set to 45. So 45 is still less than 180. So it's going to do that whole big process again until it gets to 180. And then it's going to run our else code right here. Initially, we're going to set throttle to 0. That's going to kick it off after it does the 180 to 179 and that slow shut off. And that's not something you do when you're actually coding. I just did that just to test the ramp up and ramp down capabilities of the motor and just kind of just get a good handle on the ESCs. So then you see motor 1 throttle is equal to motor 1 read. Once again, we're reading that and setting that equal to the actual value that the motor is set to. And once again, we're running our code in a loop while the motor throttle is not equal to the throttle. So while the actual throttle is not equal to our goal throttle, which is 0. And essentially, instead of adding every time, though, it's going to take it by a -1. So essentially, it's going to go from 180 to 179, 179 to 180, 178, and so on and so forth at a rate of 10 iterations per second in that while loop. It's going to keep on running that really, really fast. You could run it faster, but I just have it delayed so you can kind of have a nice noticeable shut-off period there. And finally, there's going to be an end delay once it has satisfied that the actual throttle is going to be read at 0. So it's going to be off and it's going to be equal to 0. It's going to end delay, which is going to shut it off for 10 full seconds to allow you to disconnect your power wire from your testing station. So it's very simple code just to do a ramp up, ramp down, and now you're actually ready to start expanding it, and we're going to add some 4 motors into a frame. So I'm going to design a frame for the Hobby Mate motors that I have. They have 4 screws in the bottom. I don't know how standard that is, but hopefully it is pretty standard. I will link the motors I have in the link below if you're interested in picking these up and following along with this project. So you have the exact same setup that I have. One last thing, I want to just go over the actual hardware setup one last time on how to solder those up in case you couldn't see in the first part of the video. So I'll be right back with the hardware and showing that off. All right, so you'll have 3 wires off of your ESC running to your motor. What essentially I did is just run the center to the center wire and just face them both up and wired the left to the left and the right to the right. I don't know if there's a way to actually wire those right or wrong for 100% sure. Once you get props on there, should be pretty easy to tell. On the ESC, you'll always have a red and a black wire. That's going to be your main input power. So that'll go from your LiPo battery when you're actually setting this up, or your lithium battery. For the most part, there's other alternative batteries to use, but most people use LiPo batteries. So that'll be your red, which will be your positive terminal, and your black will be your negative terminal. And then more than likely, you'll have 2 wires with a end cap that'll let them plug into the chipboard. Sometimes there'll be a red wire here too. But most of them I see anymore, a lot of them have just the white and the black. So your black is going to go to your ground on your Arduino, and your white is going to go to your PWM port that you're using on your Arduino, or if you're using this on an actual flight controller, that's just going to go to the actual control port of the flight controller, but they should have them actually next to each other, not just kind of spread out. So you can see here that the black is going to the, take my word for it, so you probably can't read that, but the black is going to the ground port over on your pinout on your Arduino, and then the white is going to my pin number 8 on the Arduino So not that you can really see that, but just look at your pin out and choose one of your PWM port pins, and then have your black go into the ground. When I have all the motors going, I'll probably have a little circuit board or something that I'll be using to kind of group all the grounds together, because you don't really have, I guess for 4 pins there are enough grounds on the Arduino, but I just don't want to populate them all with the grounds for the PWM input, so I'm just going to tie them all together, because your ground is tied together anyways as a whole on the Mega. So that pretty much wraps up the first part of this video. I have the ESC running, so I'm now ready. I'm confident that I am ready to move forward with the project. So I want to get a frame built. In the next video, I'll be designing a frame, getting it printed, and setting the motors up on that frame and testing all 4 motors at the same time, just to make sure that they're all ramping up together, and at least that all that's working together. So from then, it's going to start getting exciting and trying to get that thing to actually lift off the ground. So until next time, guys, thanks for watching. I hope you liked this video. I hope you're excited for the future of this video, as well as the series as a whole. If you have any projects you want me to build, just mention those in the comments. Definitely open to suggestions. I have lots of ideas beyond just getting a basic drone that you build from scratch. And the drone itself, there's a lot of iterations after this project, giving it FPV, making your own FPV attachment. This should be a fairly cheap build out. The biggest part is going to be how big of motors you want, how big of batteries. I haven't got the battery yet, and that's a fairly expensive part based on how much capacity you want it to have, which is going to dictate how long you can fly. And I want one that can last a decent amount of time, but at the same time, I know I'm probably going to crash it right away, so it's probably not going to have a lot of flight time anyways. So I'll probably print multiple bodies so I can have replacements as I flow through them pretty rapidly. So thanks for watching, guys. Make sure you subscribe if you like this video, and stay tuned for more great videos from Thought Provoking Tech. Zach out.